Hey guys, this morning in this little video we're going to have a look at some of our special angles that we work with fairly commonly, and ones that we need to have values for, and we can sort of manipulate them in different ways. So let's have a look. The special angles we're going to have a look at this morning are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees, and they're the common angles. Now remember, we've looked at writing angles in terms of multiples of 30, 45 and 60 and 90 and so on. Okay, so these are our sort of core ones that we need to be happy with working with. Alright, the first ones we're going to have a look at are the 30 and the 60 degree ones. Now there's a couple of ways of doing it. I'm a really visual learner, so this is the way I think about our exact values. I think about an equilateral triangle of radius 2 units, and if we drop the perpendicular down there, that'll that's a 2, bisect that base there. We've got our right angle, that's 1 unit there, and a bit of Pythagoras theorem, 2 squared minus 1 squared, we get the perpendicular being √3. And then of course here are our angles. We have a 60 degree angle there, we have a 30 degree angle there. Alright, if you want to do this on your own at any time, you can pause the video and write these for yourself just as a little revision exercise. So let's have a look at the sine, cos and tan of these. So let's do 30 degrees. Sine of 30 degrees, we've got opposite over hypotenuse, so we've got 1/2. Cos of 30 degrees, we've got adjacent over hypotenuse, so we've got √3/2. And tan of 30 degrees, we have opposite over adjacent. Tan of 30 degrees equals 1/√3. Okay, now let's do the same with the 60 degrees. Let's have a look at the sine of 60 degrees. We've got opposite over hypotenuse, we've got √3/2. And cos of 60 degrees, we have 1/2. Cos of 60 degrees we know is 1/2. Tan of 60 degrees, √3/1, which is just √3. Tan of 60 degrees, √3. Now here's a little nice little observation to make. If we have a look here, the sine of 30 degrees is equal to the cos of 60, isn't it? Okay, 30 and 60 are supplementary angles. Notice the sine and cos of two supplementary angles are the same. Cos of 30, sine of 60, once again, supplementary angles, both equal to √3/2. Now have a look at tan of 30 and tan of 60. If you were to have a look at that, remember √3 is √3/1. If you wanted to, you could think, all right, 30 and 60 are supplementary. The tan of those are reciprocals. 1/√3 becomes √3/1, which is just a nice little observation to make there. Okay, we need to know these. There's lots of really cool ways of remembering them. I basically remember a couple of triangles. So let's have a look at the other angle we've got here, 45 degrees. For that one, I remember an isosceles, right angled isosceles triangle, side length 1. So Pythagoras here we get √2. And of course our angles then in there are 45 degrees. Now anytime I do a quiz, I literally quickly scroll up these two triangles here at the top of my page so I can access the exact values for 30, 60, 45 anytime I need. Alright, and then that's a pretty quick get. Obviously we keep going, thick writing. We have the sine of 45 degrees, 1/√2. Same for the cos, 1/√2. And tan of 45, 1/1. Equals 1. And once again, we need to know these ones. Alright, for the 90 degrees and 0, this is what I remember. Now we'll look more at graphs later on, but I remember basic sine graph and a basic cosine graph. And I remember the sine of 0 is 0, and the sine of 90 is 1. And coming down to the cos, we will look at tan of that a little later on. But the sine of 0 degrees is 1, and the cos of, oh, have I got the sine of 0? Oh, sorry, that's meant to be, let me rub that out, that's meant to be cos. We have the cos of 0 degrees, which is 1, and the cos of 90 degrees, which is 0. Okay, so this is one way you can remember, either think of your sine and cosine graph for 0 and 90, and you can think of your two triangles for the 30, 60, 45. Now, I was talking to Miss Clifford the other day, and she's reminded me of a really cool way to remember. Some of you like remembering number ways, so here's a really cool way to remember it. Sine and cos, so we can think of it as a table. Here's our angle. We've got 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Let's go here. All right, let's use red here. All right, sine of 0, we know is 0. Sine of 30 degrees, if we go back to our triangles, and look, here's me, I'm just going to whip them out really quick. 1, 2, root 3, 1, 1, root 2. Okay, there's our 30, 60. Sine of 30 degrees is 1/2. Sine of 45 degrees, 1 over root 2. Sine of 60 degrees, root 3 over 2. Sine of 90 degrees is 1. Right, if we do the cosine, cosine of 0 is 1, cosine of 90 is 0. So it's like these two have swapped over, haven't they? And the cosine of 30, root 3 over 2. Cosine of 45, 1 over root 2. What have we got here? 1 over 2. There we go. So we've got our sine and cos. Tan, we can look at a special trig identity we'll look at later on, but let's have a look at this cool way of looking at sine and cosine. All right, now I'm going to rewrite a few things. I can rewrite 1 as the square root of 1, can't I? So I'm going to do that. My pen keeps getting thick. So I can write 1 as root 1 over 2. I can also write 1 over root 2 as root 2 over 2. Then we've got root 3 over 2. And hey, if you even wanted to, 1 over 1 is the same as root 4 over 2, if you wanted to. Or you can just remember the 0 and 1. And let's reverse that. We've got our root 3 over 2, our root 2 over 2, our root 1 over 2. Can you see any patterns there? Look at the denominators. The denominators are all 2's except the 0 and 1. So denominator is 2. Now have a look at the sine angles. We start at 1, root 1, root 2, root 3, and if you wanted to, root 4. So sine goes from root 1 to root 4. Now have a look at the cosine. We're reversing, aren't we? 1, root 3, root 2, root 1. There we go. So the cosine goes the alternative way, root 4 down to root 1. Once again, most of you will probably just remember the 1, 2, 3, 3, 2, 1, and remember the 0 and 1 from your graphs. But that's another really cool way of knowing your exact values. So what we're going to do now in class, we're going to check our ability to do things like this. And then we're going to move on to something called the unit circle. I need to know that you can figure out things like this. What is the sine of pi over 3? So in your head, of course, you've got to know your radian work. So you're thinking pi over 3 is 60 degrees. So in your head, you've got the sine of 60. Come over here, sine of 60. And you've got to know that the value of that is root 3 over 2. Okay, next step past this, guys, is working with the unit circle.